Alright, so today's arcs and sectors and segments. Now, on your formula sheet, so you see the formulas on your formula sheet for this section, they're all in relation to radians, but I'm going to show you what they are in degrees first, and then we'll do the radians ones. Now, you've got to know what arcs and sectors and segments are to start with. So, an arc is just a section of the circumference of a circle, okay? If you've got a small or less than half, then it would be the minor arc, okay? The smaller arc around the other side, okay, is going to be the major arc. So the larger ones are the major arcs, the smaller ones are the minor arcs. Liv? Then you could choose. It's just in relation to if they're telling you that you've got a point A on the edge of a circle and point B on the edge of the circle, and you have to find the length of the minor arc, you know that you're finding the length of the smaller section rather than the larger section. So it's not going to be likely that you get ones bang in the middle where they try and trick you and say find the minor or the major, because they're likely to be exactly the same anyway. So it's fine in terms of that, but you just use your judgment about the smaller one being the minor and the large one being the major. A chord is when you have a point on the edge of the circle connecting to a point on the other edge of the circle, okay? It doesn't go through the center. What do we call the, well, it would be a chord, but what would we call the chord that goes through the center from edge to edge? Diameter, very good. So a chord is a straight line from one edge of the circle to the other. It can be big, it can be small, and what it does is it creates the segments, okay? Please don't chatter, makes it distracting. So the segments are created by the chords. Okay, so if we cut our circle with a chord, we can have a minor segment or a small segment, or we can have a major segment or the large segment that's created by that chord. Max?
Can the segment still come sort of like a sector? Can it still look like that?
Like that?
Yeah, can they still call that a segment if they want to?
No, like if I put a line through here and made a triangle, then I could create a segment, but a segment's always made by a straight chord, whereas your sector's made by the radius of your circle. Okay, so you've got to have that straight line to create a segment. It doesn't have any elbows in it like the sectors do. So going back to sectors, so sectors are made using the radius of the circle, okay, so from the center of the circle to a point outside, from the center of the circle to another point outside, and again the smaller section is going to be the minor sector, the larger section is going to be the major sector. Okay, so that's the terminology that you have to get your head around. So if we go into figuring out what the arc length is going to be, now you're just thinking about it, so the length of an arc is just part of the circumference of a circle. So circumference we calculate by going pi times 2 lots of the radius, okay, or pi times the diameter. So for us, we're relating it back to just a section, okay, so we relate it back to the section by using the angle, okay, so an arc length, we use a cursive L to represent arc length, L for length, is equal to the angle in degrees divided by 360, because we've only got part of it, times by pi, times by the radius. Okay, so that is how you'd work out what an arc length is. Now the degrees or the angle has to be opposite the arc that you're trying to find. So if we're finding the minor arc, then we'd use the 40 degrees. If we were trying to find the major arc, then we would have to use the revolution relationship angle, so you'd have to use 320, okay, to find the major arc. So I'll give you a little moment to copy that down. So area of a sector using degrees is just based on the area of a circle, okay? The area of a circle is pi times the radius squared. We're only talking about a section of the circle, so we use our angle to put into the equation, okay, how much of that area we need. Okay, so we need 70 degrees out of 360 times by pi. Our radius is 4.1, so we're using 4.1 squared. Again, you're just putting it into your calculator to generate your answer. Pretty easy. Alright, 2A, question 7 through 9. So, area of a segment is our last one with our degrees. Now, the segment is the small section that's made by the chord and the edge of the circle. Okay, so the chord and the edge of the circle, you can see you've actually got a segment. Sorry, you've actually got a what have I done now? I want area of a. I want area of a segment. Yes, I'm trying to find the area of the segment, so I use the area of the whole sector. Okay, so I use the pie slice and I take off the triangle. Okay, so you use the area of a triangle and you subtract that from the whole area of your sector. Okay, so you would find the area of your sector first. Okay, and then you take off the area of the triangle. Now you're just using your area of a non-right angle triangle to do that. Okay, so your non-right angle triangle area is half of A times by B times by, that's meant to be, yes, sine of the interior angle. Okay, and then for your sector part, you need to do, same as we did before, the angle out of 360 times pi times the radius squared. Okay, so it's 2 sets to calculate what that small piece is actually equal to. Okay.